Tiende pamoja. Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima umo.
Hello, good afternoon guys. Welcome to MTN Teleschool and thank you so much for tuning in. My name's By Kasonde from Kafue Boys Secondary School and I'm pleased to be on this platform guys just to help you prepare for your final examinations, okay? So I am a specialist in mathematics education. Now we are going to look at 2017 mathematics paper 2. Okay, now guys, here is the thing. When you look at mathematics paper 2, it's very different from mathematics paper 1. Mathematics paper 2 mainly deals with application of topics or concepts. So in case you don't really understand what we are going to discuss now, don't worry about it. Simply leave your comment on our page MTN Zambia on Facebook. Leave your comment there. I will be able to look at the comments and get back to you as soon as possible. You can as well download our application from Google Play Store, MTN TV Plus, and watch these lessons for free. Alright guys, so we'll quickly go into our lesson and look at question number 1 from 2017 mathematics paper 2. Alright, so we look at question number 1. Alright, now question number 1. Given that is part A of question number 1. Given that matrix M is equal to 3, -2, 5, and x. So we have been given matrix M, which is 3, -2, 5, x. And number 1 of part A, they are asking us to find the value of x for which the determinant of M is 22. Find the value of x for which the determinant of M is 22. All right, so how do you find determinant of a matrix, determinant of a 2 by 2 matrix in this case? So determinant of matrix M is denoted by the symbol bar M bar, which is determinant. So what I have written here means determinant of, so this is determinant of matrix M. Determinant of matrix M is equal to the product of the major diagonal. The product of the major diagonal, this is the major diagonal, subtracted by the product of the minor diagonal, which is that one. So the product of the major diagonal, it is 3 multiplied by x, then minus 5 multiplied by minus 2. And so 3 multiplied by x, we get 3x, then minus 5 multiplied by minus 2, we get positive 10. Therefore, the determinant of the matrix M is equal to 3x plus 10. We call this as equation number 1. Now, In the question, we have been told that the determinant of the matrix M is equal to 22. So by implication, we are saying that determinant of M is also equal to 2. So I'll call that as equation number 2. Now equating equation 1 and equation 2, we have 3x plus 10 is equal to positive 2. So what we need to do now is to find the value of x. So how do we find the value of x? I will add both sides of the equation by the additive inverse of positive 10, and that is minus 10. So we'll have 3x plus 10 minus 10 equals 2 minus 10. And so when you have that, the additive inverse of positive 10 is minus 10. So positive 10 minus 10 will give us 0, which is the additive identity. So we'll have 3x, 10 minus 10 we get 0. So I will not write it there, but we get 0. Then 2 minus 10 we get minus 8. We have minus 8. Are we okay? Okay, so this is supposed to be 22. Okay, this is supposed to be 22. The gradient is 22 according to the question, guys. The gradient is 22 according to the question, so that will be 22. So now 22, when we subtract now 10 from 22, we'll have positive 12. Yes, we'll have positive 12. Now when I multiply both sides by the multiplicative inverse of positive 3, that is 1 over 3, we'll have 1 over 3 times 3x equals 12 multiplied by 1 over 3. And this will give us 3 into 3, 1, 3 into 3, 1. So 1 into 1 and 1 multiplied by 1 will still get 1. And then 1 multiplied by x will get positive x. Then 12 multiplied by 1 over 3 we get 12 over 3. And 3 can go into 12 4 times. Therefore, the value of x is equal to positive 4. That is our answer. So that is how the first part of question 1A is supposed to be answered. All right. So we go to part 2 of question 1A. This question, they want us to find the inverse of matrix M. Question part 2 of 1A says, hence find the inverse of M. All right. So now that we have found our value of x, it means that the matrix M will now be equal to 3 minus 2, 5, and where there is x we are going to put positive 4. And we know that the determinant of the matrix M is equal to positive 22. Now, we are asked to find the inverse of a matrix. Now, inverse of a matrix M, denoted by m raised to the power negative 1, is given by 1 over the determinant of matrix M multiplied by the adjoint of the matrix M. Okay? Multiplied by the adjoint of the matrix M. All right. So, how do you find the adjoint of the matrix M, which in this case is a 2 by 2 matrix? So, let's say we have matrix M, which is 3, negative 2, 3, negative 2, 5, 4. So the adjoint of matrix M, what will happen is that the numbers, these two numbers 4 and 3 in the major diagonal, will switch. Okay, they will switch positions. So we are going to have 3, we are going to have 4, and then you have a 3 there. Then what will happen to the terms in the minor diagonal? Terms in the minor diagonal will be multiplied by -1. So this term here will become +2, and this will become -5. So what we have is the adjoint of the matrix M. Now that we have the adjoint matrix, we can now find our inverse. So inverse of the matrix M will now be equal to 1 over, our determinant is 22, so you write 22 there, then multiplied by the adjoint matrix, which is 4, 2, -5, and 3. Okay, so when you multiply that, you get your matrix, which is 2, or let's say 4 over 22. Then we have 2 over 22, and we have -5 over 22. Then we have 3 over 22. So 1 over 22 in this case is acting as a scalar. A scalar is simply a constant that is multiplied by all the elements in a matrix. So when we simplify this, we are going to have 1 over, we'll have 2 over 11, and then we'll have 1 over 11, -5 over 22, and +3 over 22 as our inverse matrix of M. Alright guys, so that is how you solve, or that is how you find the matrix, or the inverse matrix of a 2 by 2 matrix in this case. Alright, so just in case you just tuned in, guys, you are watching MTN Teleschool, and you can simply go on our Facebook page, which is MTN Zambia, and drop your comments and questions there. I will be able to respond to you as soon as possible, guys. Alright, so let's continue with question number 1. We now answer part B of question number 1. Now this question, part B of question number 1, is a question on sets. So the question reads, a survey carried out at Kamulima farming block. So a survey carried out at Kamulima farming block showed that 44 farmers planted maize. So we are dealing with part B. 44 farmers planted maize. 32 planted sweet potatoes. Then 37 planted cassava. 14 planted both maize and sweet potato. Let me just use SP for sweet potatoes. 24 planted sweet potatoes and cassava. Then 20 planted maize and cassava. 9 planted all 3. So all the 3 crops, and 6 did not plant anything. 6 did not plant anything. 6 did not plant anything. Now, the first question on part B number 1, the question is illustrate this information on a Venn diagram. So we have 3 types of crops in this case. We have number 1, we have cassava, and cassava in this case will be denoted by letter C. Then we have sweet potatoes. I'll use letter S for sweet potatoes. And we have maize. I will use capital letter M. So since we have 3 types of crops, it means that we are going to have 3 sets. So illustrating this information on a Venn diagram, we'll draw 3 sets. We'll have set number 1, set number 2, and we have set number 3. All right. So we call this set as set M. We have S, which is sweet potatoes, and we have cassava. Then we have the universal set outside. Okay? All right. So now we have been told that those that planted everything, actually when answering this question, guys, make sure that you start with the intersection sets so that you are able to subtract those who are in the intersection set from the number of people who planted a certain type of crop. So in this case, we'll start with intersection sets. So those who planted all the 3 types, there were 9. So 9 will be just at that particular point. 9. Then those who planted maize and cassava, they were 20 in total. Now you already have 9 of them in the intersection set here. You already have 9 of them on the center. So it means that for the intersection set of maize and cassava, you are going to subtract 9 from 20. So 20 minus 9, you get 11. So it means that maize and cassava, you have 11. You write it there. Then those who planted sweet potatoes and cassava, you have 24 in total. Okay? You have 24 in total. So that is sweet potatoes and cassava. So we are talking about this intersection set. So they are supposed to be 24 in total. Now you already have 9 of them. So you are going to subtract 9 from 24. So 24 minus 9. And so this will give us 15. Okay? This will give us 15. So we'll have 15 there. Then those who planted maize and sweet potatoes were 14. So what you need to do is subtract 9 from 14. When you subtract 9 from 14, you get 5. Okay? So we are done with the intersection sets of all the groups. Now, we go to cassava. Now, those who planted cassava in total, they are supposed to be 37. Now, you already have 5 in this group. You already have 5 in this group, and you also have, we're talking about cassava. Okay, we are talking about cassava. So you have 15 here, and you have 9 in that group. Okay, so you have 15, 9, and you have 11. So those who planted cassava only, what you need to do is you need to sum up 11 plus 9 plus 15. When you find the total, then, okay, so we'll get 11 plus 9, we get 20, plus 15, we have 35. So when you look at the number of people who planted, okay, the number of people who planted cassava, they were 37. So we subtract 35 from 37. So you have 37 minus 35, and it will give us 2. So you have 2. So you have 2 people who only planted cassava in this case. So we do the same for maize and sweet potatoes. When you look at the total number of those that planted maize or sweet potatoes, they are 32. So since they are 32, we have 5, 9 and 15, they are part of set S. So you sum up 5 plus 9 plus 9 plus 15. So you say 5. You say 5 plus 15 plus 9. And so your total here will be 29. So what you need to do is that you need to subtract 29 from 32. So when you subtract 32 minus 29, you get 3. You get 3. All right, you get 3. So you have 3 there. Then we are remaining with one set, which is maize. So for maize, you do the same. We have 44 people that planted maize. We have 44 of them. Okay, we have 44. But then we have seen that out of 44, we have 5, 9, and 11 people who actually planted other crops apart from maize. So we still count them as part of the 44. So you sum up 5. So we are going to subtract 44 by the sum of those that planted more than one crop. So we have 5 plus 9 plus 11 plus 11. So you have 44 minus 25. This will give us 25. Okay, so 9 plus 11, that's 20. 20 plus 5, that's 25. So when you subtract 25 from 44, you get 19. Okay, you get 19. So we have 19 members there. All right. So we are done with part 1 of question number 1B. We are done with part 1 of question number 1B. So that is how you do it, guys. So you have to make sure that each time you are given sets or you are given elements of sets, you start with intersection sets and then you start dealing with individual sets, because those that are in the intersection set are not supposed to be counted twice. So you have to make sure that you start with the intersections and then you go to individual sets. All right, we are still talking about question number 1B. Now let's go to part B of B2. Part B of B2. Now it becomes simple because we already have the elements on the Venn diagram. We already have the elements. So the question is, how many farmers planted maize only? So we can see from our Venn diagram that farmers who planted maize only were 19. We can see we have 19 there. So the answer for part B is 19. Answer for part B is 19. So part B, we have 19 farmers. Then part C, how many farmers planted 2 different crops? How many farmers planted 2 different crops? So when we go to the Venn diagram, we'll see that those that planted only 2 different types, we have this group, that group, and this group. So we will sum up 5 plus 11 plus 15, and we get and we get, okay, so we have 20 and we have 31. So we have 31 farmers. Okay, and so when you look at part A of 2, that is B2, how many farmers were at this farming block? We are simply talking about the union set. So the only thing that you need to do is sum up all these. Okay, so you actually add the number of all the farmers showing on the Venn diagram, and the answer will be 70. So the union set, which is the total number of farmers, that is for part A, you are going to have 70 farmers. Okay, we can verify that. We can verify that by just simply adding. Okay, if we say we have 19 plus 11, I'm starting with set M, 19 plus 11, that will give us 30. Okay, that will give us 30 plus 5 plus 9, that will give us 14, plus then 2 plus 3, it's 5, then plus 15, that's 20. That's 20, right? That's 20. Then one thing that we also need to realize is that there is this part. We are told that 6 farmers did not plant anything, implying that we have 6 farmers outside the 3 sets. So we have 6 farmers in the universal set outside the sets. So we need to add 6 on the list, so that we have 20 plus 30, we have 50, then plus 14 plus 6, that will give us 20, and in total we have 70 farmers. All right, so that is how you answer question number 1. All right, guys, so before we look at question number 2, let's just have a quick break. I will be back with question number 2. Stay tuned.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama using no, only Zambili.
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tilo.
Cause cash money yave across Zambia.
Tituma. Ati? At bus yenda Kuchipata. Yenda South Africa. Hello, wait!
Run, K-Star, run! You got the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go.
Rise up this
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama using no, only Zambili.
Tituma. And he kept
message to you. Singing, don't worry about a thing. Cause every little thing is gonna be alright. Singing, don't worry about a thing. Cause every little thing is gonna be alright. Cause every little thing is gonna be alright.
How you use your data is up to you. With the widest network coverage, it's amazing what you can do on MTN.
This is my message to you.
Part 1, that is 2017. So we just looked at question number 1 before the break, and now we have to look at question number 2. So let's quickly go and look at question number 2. All right, we look at question number 2. So just in case you are finding challenges, guys, don't worry about it. Just go on our Facebook page, MTN Zambia, leave your comments there and your questions. I will be able to look at them and get in touch with you, as soon as possible. All right, guys, so let's quickly look at question number 2. All right, so question number 2, we have part A and part B. So part A reads, a box of chalk contains 5 white. So we have white chalk, we have 5 white chalk. Then we have 4 blue chalks and 3 yellow pieces of chalk. Yellow pieces of chalk. Now a piece of chalk is selected at random from the box and not replaced. Okay, so we have to take note of that word. It is not replaced. It is not replaced. Okay, so when we are talking about random selection, guys, we have to replace. But in this case, we have to take note of the fact that when a piece is picked, they are not replacing. So a piece is not replaced. So a piece the total number of, you actually find the total number of pieces of chalk in that box. So we have 5 plus 4 plus 3, and that will give us 12. Okay, so our sample space in this case is 12. In short, we have 12 chances. Okay, so each piece of chalk has 12 chances of being selected in this case. All right, let's look at our tree diagram. In the first trial, when a piece of chalk is selected, okay, we are talking about the first trial. When the piece of chalk is selected, you realize that. So I'll draw my tree diagram like that. So let this part be for blue chalks, then this one, okay, let me do it this way. We have blue, we have white, and we have yellow. Okay, so for the first trial, the probability of white chalk being selected, as you can see from the sample space, we only have 4 pieces of we have 5 pieces of white chalk. So for the first trial, there are 5 chances of picking a white chalk out of 12. Then for blue, we have 4 chances of picking a blue piece of chalk out of 5. Then we have 3 chances of picking a white piece of chalk out of 12 pieces of chalk. That is for the first try. Now, we have to actually bear in mind that this chalk, when it is picked, it will not be replaced. So for the second trial, the sample space will be reduced by 1. Okay? The sample space will be reduced by 1 because a piece of chalk that was picked at first was not actually replaced. So you expect the number or the total number of chalks in that particular box to reduce by 1. So let's say in the second trial, we pick a white piece of chalk. So in the second trial, when we pick a white piece of chalk, that is for white, blue, then we have yellow. So the probability of picking a white piece of chalk in the second trial will be 4 out of 11 chalks. Then it means that when we pick a white piece of chalk, then the probability of a blue ball will still remain at 4 out of 11. Then white ball will remain at 3 out of 11. Then the probability of picking a white ball, a blue ball in the second trial, we are going to have white, blue, and yellow. So the probability of picking a blue ball, it means that we do not pick, picking a blue piece of chalk, it means that in the second trial we do not pick a white piece of chalk. So here we'll just remain with 5 out of 11. Then the probability of picking a blue piece of chalk in the second trial will just give us 3 out of 11 chances. Then white will have 3 out of 11 chances also. Then suppose a white piece of chalk has been picked in the first trial. So we have white, blue, and yellow. So for the second trial, it means that the white piece of chalk is not picked, so we'll just maintain, we'll have 5 out of 11. Then for blue, we have 4 out of 11, and picking a yellow piece of chalk will have 2 out of 11. So meaning in the first trial, when we pick white, it means that the total number of white pieces will reduce from 3 to 2. So in the second trial, the chance of picking a white piece of chalk will just reduce to 2, and that is why we have these 2. So that is what is happening. All right. So we have our tree diagram. Now let's find the probability of selecting a piece of chalk of the same color. So now selecting a piece of chalk of the same color, it simply means that in the first and second trial, we are likely to pick white and white, or we can pick blue and blue, or white and yellow and yellow. Okay, we can pick white and white, or blue and blue, or yellow and yellow. Now when we are talking about probability, the word and or have meaning. So and means multiplication, and means multiplication, and or means addition. So the probability of selecting pieces of chalk of the same color, we can pick white and white. So white and white will give us 5 over 12 multiplied by 11. Then we can pick blue and blue, which is 4 over 12 and 3 over 11. Then plus yellow and yellow, we have 3 over 12, then multiplied by 2 over 11. So when you simplify the first part, which is this one, we will get, when you multiply 5 over 12 times 4 over 11, we will get 0.15151515. It will give us this number. Then plus 0.09090909 plus 0.04545. Okay, so we'll get those numbers, and when you simplify or you add these two numbers, we'll simply get 0.2 8, 8, like that. Of course, I've rounded off this solution, so the solution is rounded off. So that is how you are expected to answer this question in the exam on probability. So guys, if you have challenges on probability, don't worry about it. Like I said earlier, just make sure that you drop your comment on our Facebook platform and leave your comments there. We will look at your questions and your comments and respond to you in time. All right, so let's look at question number 2. Question number 2. Now, in case you just tuned in, guys, we are looking at 2017 Mathematics Paper 2. That's what we are looking at. Okay, so make sure you tag your friends and invite others to just watch this lesson with you. All right, so we go back to our question number 2. Question number 2, that is part B. Question number 2, part B, the question is on vectors. That question is on vectors. Now, what is a vector? A vector is a quantity with both magnitude and direction. So when you are looking at a vector, you have to bear in mind that direction is very, very important. So you have to ensure that you are showing the direction of that particular vector. Then a vector has some sort of a quantity. We need to know how long this line is or how long this distance is. So that is why we are saying a vector is a quantity with both magnitude and direction. So when you look at question 2b, we are simply looking at application of direction of vectors. Okay, so in this question, part B, we are given OP, and the moment you see OP, look at OP to be some sort of a position vector, but in this case we are not told. So we have OP, which is 2p, then vector OQ is equal to 4q, and px to xq, which is the ratio px to xq, is equal to 1 to 2. So our diagram is like this. Okay. Okay, so our diagram is like that. We have O there, we have point P, then we have C, we have Q, X, okay, then this is 2P, and this is 4Q, like that. All right, so now the question is, number 1, we have express in terms of P and OQ the vector PQ. The vector PQ. That is number 1. We are looking at part A. They want us to find the vector PQ. So how do you find vector PQ? Now, vector PQ, they want us to find the vector PQ, which is this vector from point P to point Q. So that is the vector they want us to find. So what path am I going to take in order for me to move from point P to go to point Q? So I am moving from point P going to point Q. So what path am I going to take? So there are two ways here. You can take this path. You move from P, you go to point O. Then from point O, you go to point Q. Or you can move in this direction, you go to that point, and then you go to point Q. So when you look at the diagram now, we are going to take this path because the distance of OQ and OP has been given. We have the vectors there, we have the vectors, okay? We have the vector OP and the vector OQ. So we can actually use this direction instead of the other direction. So vector PQ will be given by vector PO, then plus vector OQ. Okay, now since vector OP has been given as 2P, then it means that if we are moving in the, or if we are going in the opposite direction, as you can see, we are going against the arrow, which is this arrow here, the direction of the arrow, meaning that we have to multiply the direction by, or the vector by, a -1. So it means that vector PO will now be -2P, because vector OP is 2P. Then plus the vector OQ is 4Q. Therefore, PQ is the vector 4Q minus 2P. So when you leave it at this point, there is no problem, guys. You will get a mark. Or if you like, you can simplify this one further by factorizing. You say 2, then you have 2Q minus P. This is the same, guys. You get a mark at this point, 0.1 or 0.2. There is no problem. All right, so that is how you find vector PQ. Let's find vector PX. Vector PX. Vector PX, which is B of question number 2B2, that is part B. So we are looking for vector PX. Vector PX. All right. So looking at vector PX, we are looking at the vector from this point P to X. From point P to point X. That is the vector we are looking for. So what path am I going to take for me to get this vector PX? So you need to know that from the question you have been given that the ratio PX to XQ is equal to 1 to 2. By implication, we are saying that PX is equal to 1/3 of PQ. That's what it means. We are saying that the ratio is PX we have 1 and XQ we have 2. So the total distance of the ratios here will give you 3. That is 1 plus 2 will get 3, implying that X or PX is 1/3 of this entire line, which is PQ. So to find the vector PX, we just simply say PX is 1/3. PX is 1/3 of vector PQ. Is 1/3 of vector PQ. All right. So what is vector PQ? We already know what vector PQ is. That is 4Q minus 2P. We know that it is 4. Yeah. So I'll substitute where there is vector PQ. I'll put 4Q minus 2P. So simplifying this one, I'll just multiply this constant, which is 1/3, by each term inside the brackets, and so I will get 4Q/3 minus 2/3 of vector P. So guys, this is our answer for part B, for part B of question number 2B1. All right. So let's find C, which is part C, OX. How do you get OX? All right. How do you get vector OX? All right. So vector OX, which is the distance from this point to that point, vector OX. Okay. So I'm moving from O going to X. So I can take the path from O to P, then from P to X. Then I'll find myself at X. All right. So since we know what Px is, then we can just say vector Ox will be equal to OP will be equal to vector OP, then plus Px. What is OP? OP, we have already been given that OP is 2P. That is OP. So we write 2P and then plus Px. We just found Px, which is this one. Px. So we already know what Px. Px, we have 4Q minus 3 minus 2 over 3 P. So simplifying this, we'll get 2P plus 4Q over 3 minus 2 over 3P. Then we collect the like terms. So we'll have 4Q over 3 plus 2P minus 2 over 3P. And we get 4 over 3. Then we have P plus Q as our solution. How do you get that? Let me just take you through the process on how to simplify this part. So how do you simplify that? You see that we have 4Q over 3. Then I'm going to express this as a single fraction. So I will have plus, okay? So you are adding 2P, which can also be written as 2P over 1. So you are adding 2P, or you are operating 2P and negative 2 over 3P. Okay? So guys, when you take away 2/3 from 2, you remain with 1/3. Okay? You remain with 1/3. So what we are saying is that let's simplify this. So we have, okay, so we have positive 2P, then minus 2 over 3P. So what we are going to do is we have 6 minus 2 over 3. Okay, 2 over 3, that is P, and then we have the P there, so we'll have 4P over 3. So this part here will give us 4P minus 3. So that is what I'm going to write here. I'll write 4P over 3. So as you can see, 4 over 3 is common, and you remain with Q plus P. So that is how you simplify that question. All right. So we have one more question to answer on question 2. That is on question 2. We have one more question to answer. That is part 3 of question 2B. Okay. Where we are told that given that OC is equal to HOX. Now guys, from experience, a lot of learners leave this question out. Maybe because there is a lot of algebra involved, but I want you to know that this is the simplest question ever you can ever like meet in the exam. So this is very simple. All you need to do is play around with your algebra and answer this question. Don't be afraid of such questions. Okay, so I will show you a simplest way of doing it so that you see for yourselves that this is a very easy question. All right, so here they want us to express or show that OC is equal to OX. Now, you know that OX, we found OX, okay, let me just clear this part for now. All right, so that we pick it up from there. Okay. All right, so guys, it's good to know that you are watching. Kainda Edwin, thank you so much for tuning in. Winfrida, thank you so much, guys. Thank you so much for watching. All right, so OX, we have found OX, which is vector OX is 4/3 open bracket P plus Q. Now, part 3 of this question, we know that OC. How do you find OC? Okay, so when we go back to our diagram, OC, okay, OC, we can find OC by adding, okay, by adding OP and PC, or OQ and QC. Now, in this case, what we are going to do is that we know that CQ, we know that vector CQ is equal to CO plus OQ. All right. Okay. So, if we are given that OC is equal to HOX, which is vector HOX, by implication, what they are saying is that use OC, which is equal to HOX, to get the vector CQ, or show that CQ is equal to 4 open bracket 1 minus H/3 close bracket Q minus 4H/3P. That is what we are doing. So the distance of OC, as you can see from the diagram, the distance of OC, it is what we have been given as H multiplied by OQ. Okay, H multiplied by the by OQ. That is the distance of OC. So in order for us to actually prove, we are going to say CQ, and CQ is given by CO plus OQ. So you find that since OC is HOX, it means that if we are going against the direction of, or if we are going in the opposite direction of OC, it means that we are multiplying OC by a -1. So by implication, CQ will give us negative HOX, then plus, then OQ, like that. Then we substitute. We know what OX is. We just found OX, which is that. So we'll substitute. Then we'll have minus H. Then OX is 4/3. Then P plus Q. Then plus OQ, which is 4Q. All right. So we simplify this one. Now simplifying this one, we just have equals. So I will say negative H, then I'll distribute the 4/3. I'll have 4/3P, then plus 4/3Q, like that, plus 4Q. Then multiplying negative H by each term inside the brackets, we get minus 4HP/3, then minus 4H/3Q, then plus 4Q. And so when you simplify this, you have, all right, so when you have this, I will collect the like terms. Okay, so what I'll do is I'll do minus 4HP/3, then factorizing 4, we'll get we'll get minus, okay, I will factorize positive 4 so that I remain with h over 3, which is minus h over 3 q, then plus q, and this gives us 4 q minus h over 3q, then minus 4hp over 3. So when you look at the question, you will see that CQ has been given, and CQ is 4 open bracket, okay, 1 minus h. So what we are going to do is that we will now factorize the q from this term. So we'll factorize the q, so which is 4, and when I factorize q, I'll remain with 1 minus h over 3, then the q will be outside the brackets, then we'll have 4, then we'll have h over 3 vector p, hence shown. So this is how you do it. Alright guys, so I hope I've helped you revise on vectors and even other topics that we have talked about so far. So I'll be back guys after an hour to talk about more questions from mathematics paper 2. For now, I will leave it here. My name is By Kasonde from Kafio Boys Secondary School. So I'll see you guys. Stay tuned.
Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima